Hi, how's it going? Welcome back to the geography class. I am teacher Parit with you again as your host. I'm glad to have you with us. Today we are going to talk about a topic that continued from the last week topic. Okay, do you still remember what we have discussed in this class last week? Okay, I hope you do, because we talk about our Mother Earth physical change. So, in order to understand this change, we have discussed about the structure of the Earth. So we understand what is the part and element of the Earth that put all together to become the Mother Earth we are living on. And then we discuss about its sphere because the Earth is in sphere shape, remember? And that sphere shape we can conclude and try to study its element in terms of sphere, such as the lithosphere, the hydrosphere, the atmosphere, and the biosphere, right? So whenever what we study about the Earth, we call them in terms of sphere because it's in a sphere shape around the Earth. And then we did learn how the land will form, how it change or move. We learned how the atmosphere, the air, the gases, everything as part of the Earth are in systematic way on the Earth. And we do learn about the water, the hydrosphere, how the waters emerge, how it's run in circles, and what can we find, where can we find the water, what does it do. And we talk about the biosphere, about the living on Earth. How does it affect and change by climate? How does it uh, have an impact on different areas around the Earth? And now, in today's topic, we are going to discuss furthermore in terms of Earth physical change. But what about these change are we talking about today? Let's find out. Okay, so today we are going to focus on the physical change on other parts of the earth like topography, climate, and natural resources. But in this week, we are going to talk about the physical change on topography first. Let's move on. Physical change on topography. Topography or terrain or the shapes, the elements, or the looks of our Earth's surface. So if you look everywhere in your living life, you can see that the surface of the Earth is not the same. There are some places that are slightly elevated, some places really elevated, very high area. Some places are lower, some places are flat, some places are uneven terrain, go up and down. Some places look like rocks, some place are rockier, some places are more sandish, some places are covered in ice. So those is the many types of topography, and the physical change caused these differences on Earth's surface. And let's take a look in each process of the Earth, the physical change of the Earth that affect on topography. So let's move on. And today, the first thing we are going to talk about is the surface water process and the topography. And if you catch by the picture by now, I'm glad you did. So I really love this picture. Natural disasters, never let them stand in the way of good fried chicken. I love this woman enthusiasm that she went to buy a fried chicken during the flood. But I believe this is a fake picture just to make fun of it. But I hope it's really funny for you and brighten your day a little bit. All right, let's come back to the class and let's take a look at how the surface water process have an impact on the topography. So on land, basically, when water has completely absorbed into the land, into the soil or the rock surface, whatever the surface are, the water that is not absorbed into the land will move or remain on the surface. And when it's moved or when it's remain on that area of the surface, it will cause the erosion process on the weak surface of the earth surface. So let me explain a little bit about the water process. So more usually the water is moving. If you see the rivers, the stream, and so on and so forth. So this is the movement of the water cause erosion. And how? Because when the waters travel, there are force of the water that do against the surface. It's either it's a soil, it's a rocks, and these force causing erosion by either it's pushing against, it's scratching, or it's lifting the residue in the soil or rocks, and this residue get carried on by the water. And there are so many types, such as the small and big residue, like the big rocks, the big part of soil, that when it got carried away, this when it's traveling along with the water, the bigger and the medium size and bigger particles will cause a scratch, breakdowns of the surface in many areas as well as itself. And when it scratch, it cause, if you remember when you use the sandpaper to scratch the surface, you will see some dust particle falling off. Those are the particle, the part of the area you sand, right? So same thing with this. If the rock traveling on the bottom of the rivers, right, and the rock scratch all that surface, it causes the residue to come off. And when this residue will come off, the areas got scratched away. It lose its elements, it lose its shapes. So the particle that got scratched will get carried on by the water. The area that got scratched will change its shape. That's become change in topography. And furthermore, just remember that the erosion process did not cause the particle to disappear. It just dislocated and changed the shape, or sometimes change its uh, chemical its chemical reactions into a different elements, different chemical. So it just change or move this particle into different in terms of form. So when the particles got scratched and get carried on by the water, it will flow along with the water. And this is called the transfer process that we talk about in the hydrosphere, right? And this transferring process will end up at the middle or at the end of the water channel, causing the deposition process. Deposition is when all these particles will fall or will stuck in some place and form up to be a new terms of topography, new terms of terrain. Either it's a new land, either it's a new uh, new river, uh, new river bottoms. This is the process that done by the deposition. So in the hydrosphere, in the water process, remember there are erosion, there are transfer process, and there are deposition process. So same thing happened here to the topography. It reduced some shape, make it the area deeper, and again, when the particle got carried on and transferred to a new area and then it got deposited, it caused that topography to become more shallower or become a new land that lift over the water. So that is how the water affecting the surface in terms of its movement. But sometimes the water did not move Either it stand on its way and it still can cause the erosion process on the land. But then you will see a hole in the water source that go deeper, deeper, like if you're digging a hole and you let the water in. Remember when we talk about the land absorb water, if you first dig the hole in the ground and then you fill it with water, the water will disappear. How it disappear? Because the soil, the land, or even the rocks, they has its structure. There might be some empty space between each particle, even though it's so small, but it still have some empty space between. It makes the water goes into that empty space, and it will go deeper as much as it goes in terms of empty space until they are no longer able to absorb more water. There are no place for water to fill. Then the land will hold water. So when you fill water for a while, it will disappear until it's no longer disappear and the water will fill up the hole. That is caused by the completely absorb of water. No way for water to go down, the water will stay up. Okay, and that is cause the erosion, the way water travel down that empty structure between soils, between rocks, and when it goes, it also bring down some particle with them that cause the erosion process. So let's take a look at the, the differences of the erosion process. Number one is the sheet erosion, which is when the water erodes the surface out in sheet shape. So the surface, either it's a rock or soil, it lift up, it will erode into sheet shape. Okay, it does not go into small particles, but it lift out in terms of sheet shape. Next is real erosion. This is when the water erodes deep into the surface, like when you dig a hole and then you fill up with the water erode down either to the side, either to the lower elevated area, but no, it's go down in the vertical manners. It go down into the ground, causing the area to get deeper, 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 and deeper. This is mostly occur in the area that are equally elevated because there are no force, no gravity to make the water move, so the water stay in the place mostly, and then it instead of going horizontal way, they go vertical way. Next is gully erosion. The gully erosion is when the water eroded in wide area of the land surface. So these, if the structure are holding waters enough and there are no place for water to go. If you remember, the water will go wherever it has the space for them. It's a liquid form that can change its shape, can move anywhere that are places for them to stay. So if the area are hold enough of water and there's no place for water to go, then it will move to the different area, especially the area that have lower elevated area. So the gully erosion, the waters spread in the wide area of the land surface, as you can see in the terms of river. Okay, so this is one kind of the gully erosion process. So let's take a look. Okay, before we go, I would like you to think a little bit so I can catch my breath as well. So let's give you some couple minutes and try to list all the topography that has water go through. Like, okay, I mentioned earlier the river, so you got one. What else do you think you can find? So here's your time, couple minutes, and then we will come back. try to think the area that has water. What does it look like in terms of shape that happen or occur naturally uh, by the water process? The tip is mostly water travel due to the gravity pull, right? So just think that the water travel from the high area to the lower area, and that must cause some kind of change in topography or terrains. What are those terrains? Okay, I will give you a little bit more time, and then when you finish to list, and we will move to the example of these change in topography by the surface water process. Okay, in here, remember we talk about the surface water, which means the water were on the surface of the earth, not talk about the underground water yet. So just think about anything you can find. All right. All right. I hope you get your answer. And if you not get it correctly, it's okay. We just try to let you guess and try to think what that could be. So let's take a look at the topography that changed by the surface water process one by one. Let's start with the number one. And here we go to the next slide. Ta-da! Did anyone get the stream in your answer? If you do, you are correct. So stream, it is a water channel that mostly in the elevated area, right? Like in the mountain or in the forest. This mostly start from the water source. Either it's from the melting ice, either it's from the underground water that push the water up on the surface. And this water, we consider them as the surface water since it's on the surface of the land. Okay, so the stream you can see mostly in the forest because in the forest mostly in elevated area because people not usually build their resident on the mountains. There are also some people living on the mountains, but usually the land are on the flat surface area. But in this area, when the water comes down from the high elevated area to the lower elevation, right? The water, when it's traveled through, it causes the erosion process. Remember what we talked about in the earlier slide? That when the water travels, there are force, there are friction, there are force that move, causing the movement of these particles, either soil or rocks. And when these rocks, this particle, it either in big size or small size, when it moves, it causes friction like scratching, pushing, hitting, breaking down. It either breaks itself down into smaller particles or it breaks the surface in different area during its travel into smaller particles. That is the erosion process. Okay, and the stream is the same thing. The reasons it happens in the mountain areas more often because the rocks are more solid and strong structure than the soil, So it will be the stream will have the shape in terms of narrow channel water. So from the banks between one side and the other side are close together. Only small to moderate water channel, the water will comes down because on the side it's higher in terms of elevation and it has the structural rigidity is not easily to be eroded by the water, so it's causing the waterway or the water channel to be a narrow water channel. And this water, when it can't go on the either side left or right, it will goes down into the lower area, causing creating what we call the stream. In Thai we call ทานน้ำหรือลำธาร okay. So let's take a look at the different change in topography. Moving on to the next slide. Now, did you know what rapids means? Rapids in Thai we call Keng. Okay, if you travel or if you go to Kengkajan already, so that's it. We should call them Krajan Rapids. It's kind of funny to call that, right? But rapids in the other word, in the other meaning, it means fast movement, like really quick movement. That is the other difference of rapid. Why do they use this related word? If you can see in the picture, what do you notice about the movement of the water? They are pretty fast, right? They're so fast, faster than the other area of the water. And why? They are the reasons. There are some reason to explain this phenomenon. It's because if you can see in the background, you will also see a big rocks over there. So in the rapids, they usually have big rocks stacked in the way of the water. Why? That is because during the erosion process, like I said, rocks are the elements, are the structure that not likely to be eroded easily by the water. So when the water channel were blocked by rocks, they causing the wider area for the water travel to be narrow. And if you create such patterns of the water travel, you will see that the velocity, the speed of the water will increase because from the bigger area pushing to the smaller area, the water have force because the space were narrower, so the high amount of water have to push through this smaller, narrower area, causing the velocity to increase. And also it will be slightly different in terms of elevation, getting lower a little bit, and that also causing the velocity of the water to change as well. So in the rapids, you will usually find big rocks, different rocks on the area, causing the different or uneven uh, elevation of the surface and in terms of space for the water to push through, causing the speed of the water to go faster. And this, again, the erosion process, either it's used to be the rock over there before, or the water carry this rock until it's unable to be moved. It deposits in some area, causing the terms of increase in water velocity. We call them the rapids. Okay, and these rapids is really scary. Let me tell you a little bit how do I find it's scary. I used to be an exchange student in the United States of America. I live in Phoenix, Arizona. And in America, one of the major and important rivers is the Colorado Rivers, which came from the Colorado State on the Rocky Mountain. And these rivers were the source of the ice on the tops of the mountain that melt down and travel through the lower elevation in terms of stream and then form up together in terms of rivers, right? And these rivers, there are so many different terrains in the rivers, since from the Colorado through the Nevada until it reached Arizona is very important water source of the desert area. And in there, the erosion process, there are some area that are depth water and some area are shallow water with rocks like this, like the rapids. And when I was there, we were on the vacation with the other exchange students, right? And we get on the boat, we get on the not the boat, we use the tire of the semi truck, the inside truck tire. We inflated and then we were sit on it, and we were tied together 20 to 30 students, right? So we go as a giant raft all together. And just a moment before we hit this rapid, it used to be fun and not and very safe because we tied together with 30s of people. We are giant raft, so it's unlikely to be tipped over or stuck. And then one of my counselor decided, oh, we're gonna create some fun excitement to our students, and they picked randomly to untie the tie from the others, and they choose me. How funny is that, right? So they untie my tile, and then I got loose from the other people, so I travel only myself on a semi truck tire, and then I got stuck on one of these rocks in the rapids. So I have to get off and try to push out. So when I push it out, the water velocity are so fast that it pushed the tire away from me and I can't reach it. And what I have to float along the water using my hands and feet to push me against hitting the rocks in the water. And with this fast, I almost drown. Right? It's so tight and exhausted because the water going so fast. What you can only do is try to push yourself above the water to catch the breath. And then when the water reach to the normal uh, elevated area, right? It's become so deep you can't even reach the surface. I believe it's 2 meters to 3 meters deep, very deep. And if you heard the idioms or the phrase that Thai people used to say, "น้ำนิ่งไหลลึก," they are came from scientific or natural occurrence in terms of this philosophy, right? Because of underneath they are because the water is so deep in terms of the different in temperature, deeper it's get colder because it doesn't receive as much as the solar energy, right? uh, the change in temperature also cause the change in terms of how the water behavior, right? The density of the water, and then it causes the change in speed. So usually the water underneath is traveling faster than the water on top. So I was feeling like I got pulled down to the deeper part of the water, so I almost drowned until I can't even get my head above water. So my hands is the only thing that go above water until the other rafting person came along and saw my hand. So he pulled me off the water. So I almost died. If he did not pass and see my hand stick out into the water, I would drown and die, and nobody will notice or even find me for, I believe, with that velocity of the water, it might take years to find my bodies, or they may never find my bodies as well. So that is just how the experience of the rapids in Colorado. Like I have a story to tell that I almost died once in US. All right, so I hope you did not meet with this kind of excitement experience. It might be in terms of more fun and excitement, not near death experience like I have. Okay, so that's just how the rapids perform. Okay, so I hope you see the pictures. I hope you can think and imagine how it works from my explanation and the picture and from my experience. Okay, so now let's moving on and take a look at the different uh, change in topography by the surface water process. And let's take a look. Next slide coming up. Now, when we talk about the stream, we talk about the rivers, then there should be some mention about the waterfall, right? So I hope you get the answer in terms of waterfall. As you can see here, in this, can you guess what this waterfall is? Okay, I'll leave you 1 minute to try to think, but do not go search in the Googles, okay? 1 minute only. And let's see, do you get the right answer? If you do, it means you are people that, let's say, you knows a lot. You are having a trivia knowledge about everyday life, about travel places. This is one of the famous place. I give you a hint, it's in Africa. Okay, all right, 20 more seconds. I hope you get your answer. All right, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Bam. The answer is the Victoria Waterfalls, which is located in the Africa continent. Hooray! If you congratulations if you get the correct answer. If you don't, it's okay. So, what is the waterfall? The waterfall is also another area of the erosion caused by water and also by the lithosphere. This area mostly like it has the let's say instant change in terms of elevation and topography, right? You have instant and uh, high in terms of value of change of elevation. As you can see here at the edge of the waterfall and then to the bottom of the waterfall, there are like really high and like instantly change in terms of elevation. Okay, this one is done by water erosion and the other one is done by the change in lithosphere, right? The earth crust is lifting or submerging, causing the different in terms of area. But these waterfalls are not maybe caused by the sinking down of the other part of the earth crust, but it's not. This is still located on the same uh, earth continental crust. Okay, so it's not changed by the different uh, earth crust or the continental crust hitting each other or moving away from each other. Okay, but this is the mostly happen by the erosion process, either by water, by wind, but this, as you can see, are likely to happen by the water. Okay, so the waterfall, as you can see, they are different shapes of water falling down because on the edge are different shapes of rocks. And sometimes in these areas, there were places that you can step on. They were high. They were likely to be higher in terms of elevation than the area over here on before at the rivers that come down to the waterfall, right? So this is another effect by the deposition by the water process. The waters that came from the rivers, like all the way back, it travels through the edge over here, right? And this area is slightly more shallower than the areas over here. It because of deposition process. When the water carry on the deposit, it will stuck on here and then deposit until it form a new topography. And also, when the water falls down, right, there are faults, there are erosions, there are friction happen to these rocks, and also brought down the deposition down to the downstream of the waterfall. Okay, so I hope you see the picture. Let's move on to the next example. Now, this is gorge. What is gorge? Gorge in Thai we call Grok Than. It's The water channel or the waterways mostly happen between two mountains, right? As you can see, this used to be a mountain before. It used to be one piece. And along this, you see, there are two mountains. But what happened in the middle? The gorge are likely to affect by what? Okay, the gorge were done by the water, the high velocity, high speed water that comes down from the mountains. And with such high speed, it's like causing high impact on this area that used to be rocks or the mountains before. And this high velocity is like you are pushing drilling through these rocks, causing the water channel. And the area are usually small and narrow area, but the water is travel through, as you can see there, you can see in terms of different waves that are showing the velocities of the water. And with this color, it's slightly to be in depth. So this is one terms of the real erosions. It goes vertical way and also go to horizontal way, but in narrow terms. Okay, so this is the gorge. If you did not catch this, it's okay. So let's take a look at a different example, which is the pothole. Pothole, or if you see on the road, there are also potholes as well. Those potholes are what we call lũng bò, right? So these also occur naturally, not on the main structure, but in nature. So these potholes were formed by the water that circle around during in the water travel, okay, and it brought these small particles and scratching and eroding into the depth elevations, and that caused it to create a giant or small hole and then gets bigger. As you can see, there are different shapes, right? This is only smaller area, this is bigger area. So it starts with this and then it's increased into this. And the reason that it caused this water when it's travel this way to this way, right? And in this area with the different shapes of rock, causing them it's to circulate like this before it moves. As you can see, if it goes and then move and then goes move. If you travel to the waterfall in the streams, you can see some area that the waters did not go flow like that, but it's move and then it's circle before it's move. So that is how the potholes create. And it's not only done by the water, because when the waters get carried by the particles, the sand, the small rocks carried by the waters, when the water will go in circle, that scratch the surface and cause it to get deeper and bigger in terms of size before it's stuck in there or either move along with the water. Okay, so this is how the potholes were made, were caused by the nature of the surface water process. All right, so let's moving on. Ta-da! The alluvial fan. The alluvial fan, or in Thai we call เนินตะกอนรูปพัด so if you don't see what is shape of pad in this picture, it's right here. As you see this line, see, it's like pad when you it's like a fan, right? When you use, it's not like the electric fan, the manual fan that you use your hand and swing to create winds. Okay, so here this is the alluvial fans. Can you tell me what? Okay, I'm gonna let you some minutes over here to try to think what is the difference with these alluvial fans, เนินตะกอนรูปพัด and the rivers, the stream, the rapids that occur from the earlier slide. What are the difference between this one and the others we mentioned earlier? Okay, I will give you 3 minutes. Try to think, try to analyze what you see and what you receive in terms of information from the other slide. Okay, I will be quiet and you have your 3 minutes. Okay, almost time's up. 5, 4, 3, 2, 1, and done. The answer is these topography were created by the deposition of the particles and sediment. The other topography like stream, the gorge, the rapids, those are from the erosion process. Okay, so this topography, the alluvial vein, formed by the deposition process of the particles and sediment, but also done by the water, and the other is done by water to create the erosion process into those topography. Okay, so these alluvial veins shaped like this, as you can see, they are like that. See, different terms of terrain. This is done by water, as you can see, this likely color like that. See, the water traveled down the mountain into here, brought down this sediment, and then it formed up around this area. See, this not before is not looks like this until the erosion process by the waters and then carry down the particles and sediment and then deposit in this area, causing it to look like the fan, okay, which in this term we call alluvial fan. Okay, mostly happen in the area that have big hills and mountains. Okay, all right, so let's take a look at the different types of deposition done by the surface water process. Natural levee, or in Thai we call Kandin. So you can see here this area, this right here. This is occur by nature. It's the topography that caused by the deposition of the sediment that brought by the water. As you can see, it happens along the river source, like it's happens along the water channel, like rivers, stream, mostly rivers, levee คันดินหรือริมฝั่ง right, causing a riverbank. In this case, if you search the word levee in many pictures, they will show the picture like this. This is the flooding that happens because this usually in this area is the river, and over here used to be land, right? But the water, the flooding, because the water is higher than the rivers can bear, it flood into the land. This is the destruction of the levee, okay, by the flooding water. But in this picture, the water in the river is decreasing down to the normal level, that's making the water on the land travel down back to the river. But yes, the levee over here, this shape and this shape will happen naturally when the water is moving. For example, if the river moving this way, right, the water that hit against this shore, causing the deposition of the particle it brought along, it formed into the levee. Okay, let's take a look at the next, the floodplain. So the floodplain, what is it? In Thai, we call ที่ราบน้ำท่วมถึง right? It's the topography that caused by the deposition from the water. When the water comes along, so this is the river, the water channel is go like this. And when the water again flood into the area such as this, right? This over here, when it flood, also it carry its residue onto the land surface, and when the water reduced down, it left away those residue and form this area right here, the shapes of the flat new land that are rich with nutrition because of the many soil that will carry on the water stuck on here. Okay, usually these floodplain happen after this levee. So this is the levee, right? Levee happen naturally by the water, and then when it flood over the levee, it left over the residue, called this area the floodplain. All right, take a look at the other one, the river delta. So the river delta in Thai we call ดินดอนสามเหลี่ยมปากแม่น้ำ see it look like a triangle, looks like triangle. This surface, this land, or in the big area it look like this, right? สามเหลี่ยม triangle. This is the river channel that goes mostly out into the bigger, wider water area, or mostly happen when the rivers travel to the sea and ocean, right? And again, with the deposition process, when the water erodes and transfer these particles with the water, when the water are slowing down, because this is narrow part and this is bigger part, the velocity is decreasing, the water is becoming calmer, and that brought these particles, soil or rocks, whatever, and it deposit at this area because the velocity is slower, water is calmer, and it's able this particle to fall down and form itself to become a land in terms of triangle shape. So if you can see, wherever the rivers were able or connect to the wider water such as ocean, it will form a river delta. Okay, let's moving on. Now we talk about the surface water. Let's take a look at the underground water process that affect the topography. The underground water can cause the change in underground topography by the chemical reaction. Okay, and let me add a little bit. Not only the chemical reaction, it also done by force and friction. Like we talk about the water were absorbed into the soil, travel down through the cracks and holes. Okay, so that is another process. So mostly occur on the limestone based stone and rocks. The carbonic acid was able to erode the limestone due to its weak structure and chemical resistance. The water caused erosion as well as deposition into new topography. So just take a look over here, right, in the background, right? You see there are rocks on, uh, this is the, for example, this represent the cave, right? There are rocks that are dripping down and there are rocks that are forming up here and here, right? So this is done, the rock that dripping down done by the uh, carbonic acid that were able to um, corrode these rocks, the limestone, and then drop it down on here when it deposit, the limestone deposit, and then it form into a new shapes of rocks. Okay, let's take a look at how this works in the next slide. Let's go. For example, the cave done by two different ways, right? Either it used to be a friction done by water or it's done by the chemical reaction of the carbonic acid, right? So cave is one of another process that caused by the erosion process of the underground water. So in many areas there used to be the water underground, and as well as the water that comes down from the surface deep into the underground, right? As you can see over here, there are drips of water. See, you see over there, those are the drips of water that falls down. So which means there are water traveling down from the surface into underground, and also with the force of the underground surface that moving along it, causing the erosion of the rocks and soil or sand underground and creates an empty space such as the cave. Okay, let's move to the next. The sinkhole. Oh my goodness. If you watch the news or if you a car guy, you know the car guy, the car enthusiasm, people who likes cars, you will know about this incident, this sinkhole, this area. This is the picture of the Corvette Museum. Corvette is the sport cars brand of the Chevrolet in United States of America. As you can see here, this whole area used to be a, museum floor that exhibit the car made by Chevrolet in the model of Corvette. And these are the car. This is the real car, not the toy car. These are real, but it's take a picture from the far distance. These cars are so expensive because it has so much value in terms of collections, right? And this museum is in Florida, and sinkhole happens. It caused the collapse of surface because there were empty space or the loosen of structure underneath the surface into the ground. And when it collapsed, boom, it sinks down into a giant hole, gigantic holes. And these holes swallow many of cars into the holes. Okay, so this is the incident of the sinkhole, and I hope this picture is easier to explain than word say, right? So the sinkhole is the topography that happens on land that are mostly in terms of equally elevated or either it's in the hill, but usually uh, underground is the limestone, as you can see from here. Look at this. This is the limestone structure that holding this area in place. When it got eroded by the chemical reaction from the carbonic acid, and the limestone does not have the rigidity of its structure, and when it get corroded time by time, it losing its rigidity and it no longer able to hold the weight of the surface above it, and it collapse, causing the whole light collapse called sinkhole as you see in the picture. All right, let's moving on. Now the karst topography, same thing. These karst topography, uh, it's the shapes of rocks that looks in different shapes. Okay, it's either pointy rocks or uh, very sharp rocks or big rocks with different shapes and surface. Right, this is done by the limestone that were eroded out from the stone that it were part of. So this leftover is the rocks and stone that is have different elements in it that are not a limestone. The limestone were eroded and washed away, causing it to have different shapes and surface like this. Okay, so it used to be a pointy a length, and then it developed further into what's so-called the karst topography, like this. Okay, usually it's become like a cone shape like this, or it has holes in it, like on the top has hole go down. You can take a look down in here, right? Or it sometimes it's has like a flat, like a bowl area that hold waters in place. Okay, so this is the karst topography. And this process that we mentioned in this underground water process that affecting topography, we talk about the erosion process that caused this chain of topography. Next is the stalagmite. The stalagmite, the stalagmite is the process that done by the what the deposition process. Okay, so again, it's caused by the erosion first. Before you're able to deposit, it must be the erosion process going on first. Okay, just note that. Can deposit first because there's nothing to move to deposit. You have to erode it, carry it on, and then when you carry on, you are able to deposit those particles and residue that came from the erosion process. And again, this the stalagmite, or what we call hin ngok. Hin ngok is basically the stone or rocks that emerge from the surface upward. Let's go up. Let's go up. Goes up. Remember at the beginning of the underground water process that I talked about, when the erosion process will happen from uh, the corrosion of the limestone rocks, right, by the carbonic acid. So it erodes from top and then it drifts down. It drops down into onto the ground. And when these limestone drop down on the ground, it's what happened. It's deposit into little by little until it's reaching up, go up, go up. Okay, so this is caused by the deposition of the limestone. They were changed, they were eroded, they were corroded by the chemical reaction from the carbonic acid. Okay, as you can see in many caves, there will be some rocks that are like it's growing up like a tree, grow from the ground and up higher, bigger, taller. Okay, this is the stalagmite or hin ngok. So let's take a look at the other process. This is the stalactile, or what we call hin yoi, right? So same, we have hin ngok. Now we must have hin yoi because these rocks, this is the limestone rocks that were corroded by the carbonic acid, and then it's dripping down. The part that it got able to form itself and not dripping down into the in terms of liquid base to the ground. It were able to hold down and it's coming down little by little, okay, and the rest is drop down, go onto the ground, and then it formed the stalagmite, and this is stalactile dripping down or the dripping stone หินย้อยนั่นเองโอเค usually done by the carbonic acid, and when it will form into liquid base before it able to reach a drop to the ground, is able to holding its structure back form itself to be a rocks again, okay, and the rest that not able to form with this with its structure will drip down and create a stalagmite on the ground. Okay, let's moving on. Now we finished talk about the surface water, we talk about the underground water. Now we talk about the ocean waves. The ocean wave or the waves, mostly we talk about the water surface, the surface water that are on the ocean and sea, not the water, the fresh water that occur on the land, okay? We talk about on the sea now, mostly focus. So in the coastal area, the topography is shaped by the ocean wave, causing erosion and deposition. Again, as you can see, when there is a force by the water, especially the sea has the waves, right? These waves causing the water to erode onto the surface of the earth. For example, the coastline can be divided into two categories. The coastline are the coastal area that were affected by these ocean or sea waves, right? Number one is the emergence coastline, the emergence of the continental crust or loving sea water. Emerge means it's were able to lift up and form up the coastline. It's happened to increase in size, not decrease. That either done by the emerge of the continental crust, that the continental crust lift up, or the seawater in the area were lowering, causing the land to emerge from the water. So this is the emergence coastline, such as the categories that you can find. The characteristic of this emergent coastline are the long beach. The long beach is like the beach that have long areas of beach, and in the water of the beach have shallow water, and it slowly slope down to the deeper water, which means you can walk down and the elevation change slowly until it get deeper, but not in the terms of significant change, just slowly change, slowly slope down into deeper water. That is the emergence coastline if you found this characteristic. Next is the submerged coastline. Submerged means it's going down, right? It's submerged into the underwater on the ground, right? So submerge of the continental crust uh, is the process that causes this submerged coastline, or it caused by the rising seawater. So two ways: either the continental crust submerged on the other continental crust, or the seawater have rising its level goes up and covering and flooding into the surface. And the characteristic of the submerged coastline can be found such as there are islands around the coastline, because this island used to be the mainland, but now the water will flood over them, causing them to isolate from the mainland, leaving what's so-called the islands. And the small beach, the beach are not are very small, very narrow. So when you walk from the surface to the water, the beach area is so small and short. And again, there are deep water around. So it's unlike the emerging coastline. When you walk to the beach into the water, the elevation changes significantly. It drops instantly. So it's not go slowly, it's not slope down slowly, it's go and then boom, you're unable to stand on the ground anymore because it's look, it's drip down like a cliff underwater. So those are the characteristic of the submerged coastline, okay, which you can see in the water area around the island. Those the water elevation change significantly. It not just go down a little bit, but it slope down very deeply. Okay, just compare when you stand on the beach, on the mainland, and walk down to the water. Those elevation change differently, very slowly. That is the emerging coastline. But if you go to the water, like on the island area, it will change the elevation very quickly. Those are the submerged coastline. Just note that up. Okay, let's moving on. Sea cliff is one of the area that shows what happened with the ocean and wave process that erode into the surface of the earth. So when the force of the wave move, right, it's hit onto the surface and slowly time by time erode this with the force it hit. It's able to crack, able to scratch with whatever it carries, either it's be sand or rocks or small particles, and it's scratched slowly by slowly until these surface become loose and some particles like rock falling down or the sands or small particles were removing from this surface and get carried on by the water. This is what happened to the sea cliff. Okay, and this is again done by the erosion process. And mostly you can see there are some movement done by the Earth continental crust that cause these different shapes of sea cliff also. Alright, so let's moving on to the next example, the sea arch. The sea arch is the development of the holes in the stone and rock structures in the area of the coastal line. Okay, and because of this used to be over here used to be a giant rocks, right? But with the erosion process done by the force of the ocean waves, again scratch little by little until it's gone. It becomes so on the top still remain because it was untouched by the oceans and sea water. So as you can see here, if the water rise, it can go up to here. So this is the line showing that it's untouched by the water also here. So this is the when the waters go down, it's over here, it's scratching this area. When it's go up, it's scratching this area. But over here, this is on the top is untouched, so you can see the rocks are intact and it have different color and different shape because underneath were got eroded by the sea waves. Okay, so this is the sea arch, which is can be seen. It look like a stone bridge or rock bridge that occur naturally in nature. Okay, let's moving on. The stack again for the stack, or in Thai we call Got Hin Dong. It is like a small island. Small islands occurs around. So why it's look like this? It's because the water or the waves were able to erode and loosen up and destroy the structure of the rocks, and it falls down and left over this structure. As you can see here in this area, if we're not talking about a beach, in this area, right, it used to be like that, but the water isn't eating, eroding into the land surface little by little until it left only these rocks around. It used to be like in the back, like the cliff, the giant land over here, but the water eating in days by days, time by time, until it left only these shapes of rock. So this is called Hindle or the stack. Now bar. Okay, we talk about the bar, not the bar you go and have a drink, or you can't go and have a drink at the bar because you're not 20 yet, right? 20 or 21, right? So the bar, we talk about the bar over here. These are the bar I mentioned about. In Thai we call Sandon. It this again. Now we enter into the deposition process. The earlier were erosion process. Now deposition process. So when the water travels, right? You see, this is wider area. This is narrow and smaller area. The water is coming fast this way and then slowing down in this wide area. So when it's slowing down, it carry on those residue and then it's able to deposit the residue and it's formed into like a small land or small area that the water did not flood in the middle because of the residue were falling down and then deposit until it becomes a small land, as can be seen in many giant river like Mekong River. In the middle, this area usually were underwater when the water level were rising, and then when the water level goes down, it will able to emerge from underwater. Okay, so this is bar or สันดอนแม่น้ำ next is the beach. So the beach usually cover around the coastal area, and it has in terms of elevation, as you can see, the beach will go from lower to higher elevation. This is caused by this sea water flowing into the land, and it brought the particle and deposit into the coastal line, causing the change in topography in terms of the beach. And mostly at the beach, the deposit are from the sand that will get carried on by the underground water under the bottom, the ocean floor, right? When those residue were lifted up and then it over to deposit into the area of the coastal area, causing its a beach. Okay, beach, B-E-A-C-H. Okay, I know what you're thinking. Okay, it's the beach. All right, let's moving on. The lagoon, very beautiful areas. So what is the lagoon? Lagoon has the shape of this, as you can see. Usually there's like a giant hole over here. The the darker color represent the depth of the area. Slightly over here, it's over here is more shallower, and this is deeper. And this is usually the deep area usually to be happen in when you go travel like far into the ocean and sea, right? But not the lagoon. Lagoon may have the land like this, the shallow area, covered around this area. If you take a look into the, let's say, higher picture, you can see that there are lands like over here surrounding the lagoon. Okay, like it's either island or rocks because of this is happen when the continental crust uh, were were lifting a little bit, and then the mainland and the bar in the rivers were blocking, depositing around this area that used to be the deep area. Okay, and this is become for the seaweeds and many aquatic life to residue over here. And this is the area of the depth that usually done by the deposition around. Okay, so it formed what's so called the lagoon. And the last one of the ocean and waves process is the estuary. The estuary, or in Thai we call ชวากทะเล is the topography nearby the coastal area that it goes like this. go wider and then gets slower into the rivers area. It look like it. Take a look over here. This is area. This is the estuary, and this is the rivers. Okay, river delta over here, and back in here is the rivers that came to the open area of the ocean. And what caused, as you can see, this is the estuary, the Chawak Thale, right? It's the mix between the area, the mix between the fresh water and then the sea water. Okay, okay, let's moving on. Now we talk about the wind process and the topography. The desert is the area that topography changed by wind process pretty much. The area can be changed into smaller or bigger by erosion and deposition done by the wind. The change is not done by wind directly but done by the particles that get carried by the wind. The particle will scratch, will buff off into different shapes and carry it on the residue into the wind and it will deposit in different areas, causing deposition and form new topography. Okay, just take a look here. This is the pedestal rocks. This is the rocks that get eroded, as you can see here. This is when the wind flows, right? It carries the sand and small rocks and scratch from this side down to this. Very impressive. Okay, but it takes time, like thousands and many thousands of years until it were able to create this kind of process. The wind flows down, for example, it go this way, right? It's carry on residue and then scratch from this side to this side. That is the pedestal rock. Next is the desert pavement. This is again, as you can see, in the desert, you were thinking of sand mostly. But why this area doesn't have sand? It because this is the bigger and slightly bigger particles and rocks, and it was not able to lift into the wind. So this area used to be covered by sand like the area over there. And when the wind blows all the sands out and left over these big particles that were unable to get carried on by the winds, it caused the desert pavement. Next is the blowout. So now the blowout is another area that's by the wind. So what happened with the blowouts? It is the area, the topography in the desert that all the sand were get carried out and causing the structure of holes and places. As you can see over here, they are like slightly to non-sand, right? Because of the sand were around this area and on the sand over there. It got carried, it got blown by the winds. It blows it all out. We call them the blowouts. If you see this in the desert, if you have chance to go to the desert and see this kind of topography, you know this is done by wind and it caused the blowout. Now the pediment. The pediment in Thai we call ลาดเชิงเขาสึกกร่อน Okay, so usually in the area it's either done by wind or water. Sometimes they were raining in the desert and the waters get carried out and it corroded, causing the shape like this, right? And if it's done by wind, it takes time. Like this area, the small creek and angles and holes that goes down like this is done by either water or winds. Mostly happen from the higher to lower, okay, in terms of elevation. This is called the pediment, หรือ in Thai we call ลาดเชิงเขาสึกกร่อน Now the sand dune again. Sand dune, there are so many types of sand dune. Either it's a dome sand dune, there are length sand dune, there are curved sand dunes, there are like moon-shaped sand dune. The sand dune is the dune that created by the sand. The winds blows all the sand and okay, again, the earlier we talk about the erosion process. Now we talk about the deposition process. After those, wind carry on the particles and it deposit into giant dunes like this. The dunes have many shapes and it changes all the time. Okay, because of the wind blowing, then it's changed because the sand is moving to the other directions, changing the shape of the sand dune. Next is the loess. The loess, the loess is in Thai we call Din Lom Hop, right? So it's the area that the topography that caused by the depositions of sands that blows, and there are no shapes. It can either be in the layers or in flat or in uh, hills. This the lowest will not hold in place. It done by the winds that blow to the sand. It will shape into in different shapes, and then it will blows again and changing shapes all the time, just like the sand dunes. Okay, so now let's finish with talking about the wind process, and we enter to the last process we are going to talk today, which is the chirosphere and the topography. The chirosphere, it's another sphere that we did not mention in the structure of the Earth. The chirosphere, they talk about the cycle and the process of ice on Earth, right? How the water change into ice and ice change into water, or what are these ice causing in change of topography? And we are going to talk about it here. Cryosphere plays significant role in changing topography of the Earth. Earth's pole and high altitude area like mountains are affected by the cryosphere. The deposition of snow that didn't melt has formed into glacier. So mostly snow in the cryosphere process. So when the waters get cold, it becomes ice, and then when the temperature gets higher, the ice start to melt into water. But sometimes these ice were not able to melt all of them, and the leftover ice will form harder and stronger into what's so called a glacier. In Thai, we call Than Nam Kheng. So the glacier can divide into the Alpine glacier, which is from the on top of the mountain, and the continental glacier, which is from in Earth's pole area. Okay, the difference between two again, continental glacier happen in the north, in the Earth's north and south pole of the Earth, and it has large and much larger glacier. It's can either wide in kilometers wide and big in terms of length and width. The area of the glacier can go up to in kilometers, which is larger, slightly much larger than the Alpine glacier, which is on the tops of the mountain and is not as much as large as the continental glacier. The glacier caused erosion and change in topography because of the sediment that brought in by the glacier will deposit and form the new topography. This is the cirque. The cirque this okay, this is the process of erosion. Okay, so this is called the cirque. In Thai we call หุบเขาทานน้ำแข็ง cirque, right? It's the topography that caused by the erosion of the glacier on tops of the mountain, and it caused the shape of like U shape in the area because on this area we use the glacier on top falls down, right, and erode the areas like time by time until it's become like the U shape. Next is the arete, or in Thai สันเขา arete, right? This is the sharp area over here. This is done by the glacier. The glacier on top, when it's melt, it goes down, or when it falls down in terms of the avalanche of any things, when it move along, it scratch, it buff until all the top of the mountain, top of the hill become a sharp and pointy uh, hilltop or mountaintop. Okay, and it usually have very long like this. Yes, carry along like the long topography. This topography, this type of topography done by the mountain glacier or the alpine glacier. Next is the horn. So the horn, as you can see, it's go into like a pyramid shape, right? Pyramid shape. This is also done by the glacier. When it's melt and falls down, it creates the change on the rocks, causing erosion into the pyramid shape. Next is tarn, or in Thai แอ่งน้ำบนเขา so area this is caused by the erosion of the Alpine glacier and it caused a small lake or swamp nearby the mountains. Very beautiful. This usually happen in the cirques hills of the glacier on the mountain that were causing when it melts. If you go back to the cirques, it's go into U shape, right? And that U shape later on, uh, time by time will become turn. Okay. Now talk about the deposition process. This is the cane, not game, nah. It's cane. Cane is like the hills, this area that happen by the depositions done by the Alpine glacier. Okay, so when the glacier will melt or travel down, it brought the residue such as rocks, sands, and soil. When it's all melt, and then those residue within the glacier will form into these small hills, like against each other, like this. If you see these types of hill, you know that these topography were done by the Alpine glacier. Next is the kettle. The kettle is in Thai we call หลุมทานน้ำแข็ง This area used to be the glacier. The glacier. When it's all melt and the water were dissipated and moving away, it left over a hole and this is going deep down, deep inside because it used to be the glacier. Now it's melt into water. It's become a small swamp or small lake. Okay, this is what's so-called kettle. And then the till ตะกอนทานน้ำแข็งไม่แสดงชั้น so as you can see it's not showing layer, it's just a deposition of the residue done by the glacier. Okay, so this deposition did not that were under the glacier did not transfer to the other area and it deposit in the area of the glacier when it were melted. So there are no deposit into layers of sand, just soil and particles over on each other, not causing any layers and differences in terms of deposition. Okay. Next, the glacier lake again. The glacier lake is happen when the waters get surrounded by this glacier and the mountains area. Okay, when this glacier were melting and it falls down to the area that were surrounded by rocks, it formed the glacier lake เป็นทะเลสาบทานน้ำแข็ง which can be seen in many areas such as the hillsides of the mountains. Okay, so that's it for today that we talk about the physical change of the Mother Earth that affect on the topography. And the next week we're gonna talk further how the physical change of our Mother Earth affect on climates and natural resources. Now is Q&A time. Okay, if you have any questions, please leave your questions and inquire any suggestions in the Q&A box created in Google Classroom. And no further ado, thank you for attending class and have a wonderful day. I'm really glad to have you with us and see you again next time.